Dear students, today we will discuss the assembly language programming of 8051 microcontroller. The, the program concept is write an ALP program to compare two 8-bit numbers, number 1 and number 2, stored in the external memory location 800H and 8001H. So reflect your result as if number 1 is less than number 2, set LSB of data RAM location to FH. Okay, that bit address is 78H. If number 1 is greater than number 2, set MSB of location to FH. That bit address is 7FH. If number 1 is equal to number 2, I need to clear both LSB and MSB of bit. The memory location is 2FH. So this is a logic. Okay. So this you can see this 2022F is bit addressable location. Right. In the program what they are asking, if number 1 is less than number 2, I need to set this LSB, least significant bit, as 1. If number 1 is greater than number 2, I need to set MSB bit as 1. MSB, most significant bit. If number 1 is equal to number 2, I need to clear both MSB and LSB is 0 at the location of 2F. This is a logic. Okay. Now we'll go for a program. Now, so to better understanding, I will update the data in tabulation also. You can check. First instruction, move dptr hash 800H. This hash determine immediate value I am sending to dptr. That means dptr, the current address location is 800H. So dptr, the current location is 800H. Okay. So at dptr means this 800H, it holds some data, right? So dptr, that at dptr, that is 800H. Let me take this hold 15. Okay, that 15 have to transfer to accumulator. See, transfer the content of at dptr to accumulator. Move x, you can see here the x I have added. The reason is when you want to transfer the data from accumulator, that is internal location, to the external memory location, you want to use this type of instruction. So this is a indexed addressing mode, right? So move x, so this is the instruction used to transfer data from internal memory location to external memory location. Very important. So after execution of this instruction, this is the content. Right. Now if you go to the third line, if you execute, that is content of A, I am moving to R0. The R0 will be updated as 15. So because I am moving that data to 15. Now I need to increment the dptr. So if you increment the dptr, it will be updated as 8001H. So the content of 8001H, let me take 10. That is moving to accumulator. So 10. So after execution of this instruction, you can see the accumulator update data is 10. So I need to clear the carry flag. Very important, because by checking the carry flag only this entire logic is going to work. See now, sub B A comma R0. That means A, we perform the logic of A equal to A minus R0. What is the A here? Current updated value is 10. And R0 is 15. Right. So you can see 10 is smaller number and R0 is bigger number. If you subtract this number, surely you need to get the borrow. So if you want to get the borrow, you need to set the carry flag. Right. If you do the subtraction, what you will get, let me check. See, like a value is 10. If you write in terms of binary 0 0 0 1 and 0 0 0 0, and your R0 is 15, so that is 0 0 0 1 1 0 1, sorry, 0 1 0 1. Okay, so 8421, so you get 0 1 0 1. This is for 5. Okay, so you can see 0 cannot be subtracted from 1, so you need to get a borrow, so that means carry flag will set. So if you do the calculation, you will get 1 1 1 1 0 1 1. So this is hexadecimal equivalent of this calculation. Okay, so that is 1 1 1 and 1 0 1 1. So if you want to see your actual number, what you need to do is, so 1 1 1 1 0 1 1. Okay, you want to take a 2's complement. So first you can, I'll share the shortcut key. So first write the one value, the rest of the values you need to convert, complement. That 1 0 1 0 0 0 0 0. So this is the 2's complement of this number. That means you get 0 5. So you can see your number, your MSB is 0, your answer is 1. That means magnitude is changing, so minus 5. So you can get this number minus 5. Right. So what you understand is, if you do the calculation, you have a carry. Right. So now we'll go here. So what is the current A value? 10 and R0 value 15. So if you subtract, we know that carry flag will set. Right. Now you can set the condition, first condition. Both are equal or not equal. So condition fails. Jump if carry is not set. Right. So this also fail. So that means where I need to go, this is a logic I need to perform. That means I need to set the here LSB. See, what is the condition here? 7F. That means MSB, right? Sorry, number one, if it is greater than number 2. Okay, what is the number 1 you consider here? Number 1 is R0. What is the R0 value? 15. What is the A value? Number 2 is 10. Right. That means 15 is greater than 10. That means which condition will work? This condition will work. So if number 1 is greater than number 2, I need to set the bit address 7FH. Right. So go to this. So our program is correct. Right. That means this MS will become set. So because we know that R0 will consider as a number 1. R0 number 1 and A is number 2. That means your 15 is greater than 10. That means I need to set MSB as 1. The MSB location is 7F. So that's what we are doing. Right. Then short jump end 1. So you need to come here. You want to in the program. Suppose consider A is 10, B is 10. So what, both conditions are equal. So jump 0. Where I need to go? You need to go to this loop. I want to clear both the LSB and MSB, right? So this is your 2FH, the MSB, LSB. So this is your MSB, this is your LSB. Both will become 0 0. So consider another way. A is 15 and B is your R0 is 10. If you consider this logic, so what, you don't have a carry, right? You will not have a carry because we know that A equal to A minus R0. So A here is 15 and B is 10. So higher number, there is a lower 8 bit. So carry will not be set 0. So jump if carry is not set. So you need to go to the small and you need to set 78. Where is the 78? 78 is your LSB. So I need to set it as 1. Okay, so this is a way how your program is working.